to scroll forward, get you some graph paper, visible, color choice. Took too long. That's terrible. Different color choice. Oh, this one is better, bolder.
Yeah.
Little plus, give you a little more room to write, and it's all yours.
Okay.
Oh, she's nervous.
I'm
Who will
not
yell
sure
at
about
her,
this
make me
one.
more nervous? Emily Manship! She on? Yeah, there she is. Emily Manship, you're in charge of making sure she does it right.
Okay.
You see something wrong, be gentle, give her nudges, don't tell her exactly how to fix it. Always. Always, all harmonic motion, pendulums. Anything goes back and forth. You put a spring on put a mass on a spring and let go, it goes up and down. Same model. Time this way, height this way. Same exact model. It's a beautiful thing for those sorts of applications. We're getting an example that I'm going to point out how we next use graphs of seasonal weather patterns. And trees is what we create. And it repeats over time in a regular way. You can be modeled out. Get Marianne. Okay, I lost track. Good, well, that's good there. So far, so good. Cosine curve. Got that. Now probably calculate the period. Look at that. Whoa. Beautiful. Pressure down 5. Go, pay attention, focus. Yeah. You ain't done it here. You ain't done it. Make sure you guys got it. One of ones where the test either goes well or it goes badly. We're on number 7. We got to do 3 more things. So, wow, at least 2 class periods to get the quiz. This is the key. If you got this, then everything kind of hooks in it one way or another. Shifting to the right, fire the 2, beautifully done. Sure.
So the 3 at the start brings it, makes it go up 3, still.
Makes the height of the wave 3 above the middle line. And it makes it go down 3 from the middle.
So for this one,
usually it's at 0. But if I shift the whole graph up or down, that's going to change, right? The whole thing, it's going to be upward plus or minus the middle line.
I should have 4 and 2.
4 and 2. So that's good. Now you need now Mrs. Knight, you would want to continue it to the left, right?
Okay,
You have to do that part, otherwise they have to mark it wrong on the test sort of thing.
right, just to the zero,
Yeah, just the zero, because you have to fill the graph paper, right?
right,
So you keep going to the left.
okay,
Okay, and see how you left an open circle there?
yes,
That technically is a little point there. You're gonna fill those in.
okay.
Why do we start at 4 high?
Well, she did. She noted that the height of the wave is what? Supposed to be what?
1 to 4, 1.
Right. So that's where she started. And so where does cosine start?
1.
At 1. So she started at the high point, right? And then she had to phase shift it pi over 2 to the right. So her first point's actually going to be to the right, pi over 2.
It should start at the high end of 2, right?
So, yeah, so at pi over 2, she started at her high point. Her high point is going to be, the middle is at 1, and she's 3 above the middle. So that's
Well, why
why.
wouldn't we just start at 1?
Because the height of the wave isn't just 1, it's what? 3. And so she should start at 3 above the middle line. The middle line got shifted up 1.
Oh, that's why
Starting
she
at
started
4.
at 4.
Right? So our first thing was it starts at 1. Then she noted it starts at 3, right? Then she had to move it pi over 2 to the right. She would pi, so. Emily didn't say anything.
Yeah, I'm trying to figure out my ground.
Okay, so she started here, right? This is her first thought idea, right?
Yeah.
Then she said, all right, amplitude is 3. I gotta start at 3 instead. Right?
You automatically, whatever that first number is, that's where we start.
Well, if it's sine, it's gonna start at 0, right? That's gonna be, your height is gonna be 3 when you get to the first spot. Right? But the height of the wave is now 3, so at the highest point it should be 3, not 1. There's no number there, it's 1 and negative 1. But if there's a number there, it's going to be 3 and negative 3 or 7, whatever it happens to be, right? Okay, so she started there. Then she did a phase shift of, well, then she did a period. So she noticed she had to repeat here, but that doesn't change where this point is, right? Then she said phase shift pi over 2 to the right. Wait, hold on. Yes. Was it negative to begin with?
Yeah,
Okay, good. You and I know what we're talking about. Everybody else should know. Okay, so she got a negative pi over 2, so she knows pi over 2 to the right, so she moved it this way, pi over 2. Then she had to lift the whole thing up 1, so this point had to go up 1. And that's where she started. Okay? And so she got this part right. Now again, I would ask that she go back down to here. That's not right. It should be like this for her actual graph. Okay? Because she really should graph it for left and right the whole way, just by backing down the graph.
Mr. Rusney,
Yes, ma'am.
wouldn't this go all the way down to -2 on the Y?
It does. That's where oh, erasing your
Well,
stuff.
just like where you continued the graph from pi over 2, shouldn't it go all the way down to -2?
Yeah, but
instead of
Oh, let me double check. Oh, I think you're right. I think I blew it.
I heard about
Yes. Okay, should we go back to hold on. Let me double check what she did here. She did what? Yeah, no, you're right, I'm wrong. It should go like this, and it should be all the way down here at -2. Right? Because it should go through there. Thank you for catching that. Does that make sense? Yeah. I'm the one that drew it badly, so you know you think. All right.